Okay, so first we're going to start with finding solutions of cosine equations. Now we've kind of already done this. So we talked about inverse functions earlier, which is kind of the same thing of what we're doing here, except right now we're not going to have any domain restrictions. So this question is saying what value of theta, when I take the cosine of it, is root 3 over 2. So you can see right here at pi over 6, we're at root 3 over 2. And then right here at 11 pi over 6, I'm at root 3 over 2. However, those aren't the only values. If you think about it, it's any angle that's going to end right here on the unit circle or right here on the unit circle. And there's lots of angles. It's an unlimited amount actually. So for example, if I went around 2 pi and then added pi over 6, I would still be at root 3 over 2. If I went 4 pi and then went to pi over 6, I'd still be at root 3 over 2. And the same thing happens for 330 or for 11 pi over 6. So the way that we end up writing these, and we're going to talk about this on the next slide, is it's not just 11 pi over 6 and pi over 6. It's going to be all of the values it's going to be this and this plus some iteration of 2 pi. So 2 pi is all the way around the circle. So k always ends up standing for an integer. So like 1, 2, 3. So if k was 2, that would be 2 cycles around the unit circle, and then you add pi over 6. If k was 3, that would be 3 circles around the unit circle. So 1, 2, 3, and then you'd add pi over 6. So that's how we end up writing these, just because it's not just these two answers when this is written generally. It's going to be all the versions of those, all the different angles. So this type of problem is the same kind of thing, except here we don't have the cosine isolated, so I need to get it by itself. So the first thing I'm going to do is subtract by 1, and I end up getting negative cosine of theta equals negative 1/2, which gives me cosine of theta equals 1/2. So now at this point, you're finding all values of theta. When you take the cosine of it, you get 1/2. And again, there's going to be an unlimited amount of them. So we have, let's see, cosine equals 1/2 right here at pi over 3. And then also at 5 pi over 3. And then again, we're going to add all of those revolutions around the unit circle. And then if you were solving something where you actually had to use the calculator on it, because we don't have any value on our unit circle where we get 2/10 that we can easily see, you'll end up going through, taking your calculator, and you'll do the cosine inverse of this. When you plug that in, you'll end up getting that theta is 1.37. And then notice here it was pi over 3, 2 pi minus pi over 3. So the other theta is going to be, because again, when we do the cosine inverse, that restricts the domain, but there's no domain restriction for this answer. So to find that second value of theta, you subtract 2 pi from it, and you'll get about 4.91. And then again, you have to add 2 pi k to both of those to find all the iterations of them. Generalize this now. So in general, trig equations may have infinite solutions. Therefore, the domain of the function must be considered when solving. To find all possible solutions of a cosine equation with period of 2 pi, recall that the cosine of theta equals the angle plus 2 pi k, which is what we just talked about on the last slide. Or if we're dealing with degrees, it'd be the 360 degree k, where k is an integer. Also, note that theta is the angle produced by the calculator. And additional angles can be found by doing that 2 pi minus the angle that you find when you solve that. So for example, if we had to solve exactly theta is root 2 over 2, and here we have an actual domain restriction. Okay, well we know that cosine equals root 2 over 2 at pi over 4. And then again, cosine is positive here and here. So it's going to also happen at 2 pi minus pi over 4. So to figure that out, get a common denominator. So 8 pi over 4 minus pi over 4, which gives us 7 pi over 4. And those are just your answers, period. Because again, they told us that we were only looking for angles between 0 and 2 pi. Now over here, this bullet point, you can see there's no domain restriction. So we need to list all the values that are going to give us that, which is an infinite amount. So you take your angle, you put the two values that you found, and then you add 2 pi k. And then to be mathematically correct, we need to kind of define what k is. And so we say where k is an integer. The other way that you could write that mathematically, if you want to have some shortcuts, it's k is an element of the integers. It's kind of weird, but this is basically says exactly what this does. I'm fine with either way.